Hi there guys, this is Cody Kitchens from Group 16, here to present to you our music box presentation. You can kind of see by way of introduction just some of the aspects of our design that we feel exceed the requirements. We did come in under budget significantly, and thanks to Kyle's design, and all the instruments actually exceed the space requirements that you put before us. In fact, Kyle's instrument and another instrument could probably fit inside the design of mine, which you'll see in just a second. I had the low voice percussion instrument. You can kind of see that it's a marimba instrument inside of a box. You can kind of see some of the physics of the calculations that I did there and just how I got the standard bar lengths. Here you can kind of see just basic tech drawing just to get a real rough idea of what I did. Here you can also see the physics behind the bars that I used, how I actually had to shave the bars in order to achieve the correct frequency. And you can kind of go through a little bit of how I did that. Now it did kind of go through some changes in design using whitewood bars. You can actually see here, this is the design that I have right here. You can see it's actually plain and fully functional. This is just a little bit of my cost breakdown and the dimensions of everything. You can see that everything checks out. We're under budget and we are under weight. As far as challenges, I did come into a little bit of those as far as the oak bars go. Couldn't drill into them completely, so I ended up using a combination of liquid nails and actual, 1/8" nails. And for changes in the future, we will be probably using a smaller box and fastening the bars with wooden dowels. All right, thank you very much.
Hello, this is the flute design. Here you see a rough schematic just showing the top half. What you see here is the notes are length equally spaced apart based on the frequencies we desire. It weighs in a ½ pound. It's 9 inches. It costs $1.98 or $2.98 with painting, and it's within 5% of the reference calculations. The physics here are just for reference. Please take a look at them. The wind instrument, the bill of materials, it comes out to $2.98. The challenge is not everyone's born to play a flute. You actually need an embouchure. The thickness of the PVC pipe made all the difference. Changes in the future, I would build a mouthpiece first, and then I would use it to create a reference airspeed, and then redo the calculations. Thank you.
Hi, this is Zach Johnson from Team 16, and this is my ukulele jewelry box. Just to give you a quick overview of the dimensions, here's a 1-foot roller. To give you a brief overview of the physics, so basically to increase the frequency of the string, I would tighten my tuning machine, which would increase my frequency. To lower it, I would untighten it, basically just changing the tension. This is my tech drawing. As you can see, it is a very close representation of my current model. For precision tuning and accuracy, I used Audacity. I was able to locate the exact frequency. Changes in design. There's several minor changes. For the wooden tail, I replaced it with 3 metal screws. This was a lot faster. On the neck, you can see this is an upright. I just basically changed that because of spacing. Cost breakdown. The total cost of my instrument costs $12.47, a couple dollars under budget. Challenges and improvement. Basically, the main improvement I would do is apply a bolt or screw along the strings to help guide them to get rid of the rattling noise you may have heard earlier. That concludes my presentation.
Hi, and I'm Angel Martinez, and I actually created a cigar box guitar for the high voice in the string family to be able to play Ode to Joy. If you look, it's pretty straightforward. If you look, so there's some of the listed features and important what kind of sets it apart. Compact, very, very easy design. Guitar is attached to the cigar box with just a piece of wood and a couple of bolts. Nut and bridge are made out of machine bolts and nuts as well. And here's some, for the tuners of the guitar, just some eye bolts. And then if you listen, there's your pretty much how you would go about playing it. But very simple design, kind of allows you to do a no rules approach. Now some of the physics behind it, if you take a look, basically what I did was a pretty simple design. You just take the fundamental frequency of a guitar string already, of a traditional guitar string, based off of that, and the scale, which here from here to here is 12 inches, which is between the bridge and the nut, which are these 2 points right here. And then you calculate the length of how much you have to shorten the string to get the desired frequencies that you see listed here. If you look here, here's the tech drawing. Initially, it pretty much for the most part has remained the same, has not changed. So if you take a look at this, some more kind of physics behind it. Again, all about finger placement here, and kind of referred to it in an earlier slide, but 12-inch scale from the bridge to the nut. And again, 12 inches from here to here. But what happens is you strike, and it creates movement within air molecules, essentially. That is what gives you your notes. You shorten the length, it'll give you a higher frequency because there's less, it's basically shortened path for energy to be displaced, so it just gives you a higher frequency. Change in design, nothing, it's for the most part has remained the same. A couple things, well, the one thing that did change were the strings. Initially I was using the fifth and sixth string. Didn't work too well because of the fact that it was strings were just the fundamental frequency was just too low. So we moved to the first and second strings, and it allowed to get the correct tension to be able to play the correct notes that you saw earlier as well. So you take a look at the breakdown of the cost. This has remained the same. The total there, if you look kind of what you can basically what you see there, it's a total cost of about $13. All parts that can be acquired from a regular general hardware store. Now some of the challenges and some of the improvements, you see some of the challenges were really the scale was 12 inches. It was too short. It's kind of hard to get the notes that you want and the frequencies. So lengthening this up might be something for change in the future. Calculating the space between the frets of where you put your finger placements for the notes. You're getting there's space a little close, so again the neck being a little bit longer. And then also some of the challenges were the other challenge was the butterfly bolts. Really to keep them tight was kind of a difficult thing, even though you had this butterfly nut on this side, basically keeping these from turning. One big design change that would be implemented here is going to be the neck. The poplar wood is just a little too soft, so we would have to use a hardened type of wood, just so that way your guitar or the cigar box guitar would stay in tune for a little bit longer over the length of time when you're playing it. Thank you.